We have showed that many algorithms which perform very well on labeled faces in the wild dataset degrade by more than 10% in accuracy on our dataset. We believe this dataset will provide a very good benchmark in future to understand the problem of pose variation in wild. So, labeled faces in the wild dataset. Over the past 10 years, accuracy on this dataset have improved from 70% to almost 100%. The question that comes into our mind, is the problem of face recognition solved? We believe not. Looking at the images of LFW, we see that most of the images are facing the camera, so the amount of pose variation present is pretty much limited. So to handle the issue of pose variation, because in real-world application, in security application, we don't get images facing the camera. For this, we need a dataset that has large amount of pose variation. This is the purpose of introducing this new dataset, celebrities in frontal profile. We have images of a person in frontal that is facing the camera and in profile that is in the side view. So we are given a pair of images of a person in frontal and profile. We want to say if they belong to the same person or not. So this dataset contains images of 500 individuals with 10 frontal images. We define frontal as facing the camera or the yaw angle being less than 10 degrees. We have 4 profile images per person, which is the profile we define as side view, and the yaw angle is more than 60 degrees. The experimental setup is same as LFW. We have a 10-fold verification problem with 350 same and 350 not same pairs in each fold. We tried several different publicly available algorithms. So we used HOG and LBP features, extracted over 30 key points and forming a very high dimensional feature, which we reduced by PCA. We used the Fisher vector faces. We used two metric learning method, sub-SML and diagonal metric learning. All of this performed very well on LFW. We used a deep network, which has been presented in the last talk. When we see the results on the frontal split of our dataset, we kind of see the same what we expect from their performance in LFW. The deep features perform similar to the human accuracy. While going to frontal profile, we see the humans perform almost good as frontal, 1.5% less, not much. We evaluated the human accuracy by showing the pair of images to mechanical Turkers and asking them to rate the similarity of these images. Now going to the handcrafted features, we see the accuracy of most of them degrade by more than 10%. And also the deep feature, it degrades by more than 10%. So to conclude, we see that most of the algorithms that we evaluated, their performance fall by more than 10% in the dataset. So the question that the dataset raises is how can we create an algorithm that can handle the pose variation along with other in-wild variation. While creating this dataset, we noticed that it's very hard to obtain a large number of profile images of a person, especially celebrities, because most of the celebrity images that you find are frontal. So if we want to train a deep network, we would need at least hundreds and thousands of profile faces of a person, which would be very difficult to obtain. The question that we raise is how can we efficiently learn a deep network by using the small amount of profile images that we have and still do very good than not training anything on profile images. Thanks for listening to the talk. We will